In this lecture, you'll learn how to configure your switches to support your wireless network. I'll start off first with the configuration for autonomous standalone APs where we're not using a wireless LAN controller, and then I'll show you the config when we are using a wireless LAN controller. Okay, so before I show you the configuration, there is a difference depending on whether it is an autonomous or a lightweight AP. So let's review the traffic flow again so you can understand why we do have that difference. And I'll start off with the autonomous AP. So you can see in our example here, I've got a couple of wireless LANs, the guest WLAN and the corporate WLAN. And we've got a wireless AP with a couple of clients connected in there, and it's connected into the wired network. First off, let's say that a wireless client, which is in the corporate WLAN, sends in a frame to the wireless AP. So it comes in on the corporate WLAN with the corporate SSID. The wireless AP is aware of that. It then sends it to the upstream switch, which it is connected to, and when it does that, it is going to tag it with the associated VLAN. So it's going to be tagged for the corporate VLAN. Then that will then be sent on to the final destination by the switch, just as if it was any other normal packet. Then let's say that the laptop, which is connected into the guest WLAN, it sends in a frame to the wireless AP. Well, in that case, the wireless AP knows it's coming in on the guest WLAN, which is associated with the guest VLAN. So it will tag it with the guest VLAN and send it on to the upstream switch. And again, the upstream switch will forward that as it would any other packet. So you can see when we're using an autonomous AP, the AP is going to be tagging the frames and sending them on to the switch. And because there can be traffic going for different VLANs there, we're going to need to have a trunk configured between the AP and the switch to support those different VLANs. So let's look and see how we would configure it. Again, it's the same example. We've got two wireless LANs, and we've got the corporate WLAN with VLAN 21 and the guest WLAN, which is mapped to VLAN 22. So we will create our VLANs first. So at global config on the switch, I have said VLAN 21, name corporate, and then VLAN 22, name guest. Then I need to configure the port on the switch, which is connected into the AP. So in our example, it's interface gigabit Ethernet 101. I need to configure it as a trunk. So I say switch port trunk encap.1q. Now, depending on the model of switch, you might not need to put in this command. Some of the newer switches only support .1q anyway, they don't support ISL. So if only .1q is supported, it will give you an error message when you put in this command because it is all it supports. But if it is a switch which supports both .1q and ISL, you need to specify it's .1q you're using. So say switch port trunk encap.1q. Then say switch port mode trunk. And switch port trunk allowed VLAN 21 and 22 for the VLANs that are coming in from the AP. Okay, so that is our switch configuration where we're using standalone autonomous APs. Next up, let's look at what we do when we do have a wireless LAN controller. And there's a different traffic flow now. So here, we'll go through the same example again. And the laptop, which is in the corporate WLAN, it sends in a frame to the wireless AP. Now, the wireless AP does not now tag it with the corporate VLAN and send it on to the attached switch, which will send it to its final destination. No, the wireless AP is going to send it to the wireless LAN controller through the CAP/WAP tunnel. So at this point, the wireless AP is not tagging the traffic. The frame gets sent through to the wireless LAN controller. The wireless LAN controller then sees that it is for the corporate VLAN because that information was included when it was sent from the AP, and it is a wireless LAN controller which will tag it with the corporate VLAN, send it back to the switch again, and the switch will then send it on to its final destination as it would any normal packet. So when we are using a wireless LAN controller, the configuration now is it's the wireless LAN controller which is going to be tagging the frame. So the link between the switch and the wireless LAN controller needs to be configured as a trunk. But the link between the AP and the switch, that is not configured as a trunk. It is configured as an access port. So we're going to configure a management VLAN for traffic coming from the AP to the wireless LAN. All frames are going to go through there with the same VLAN. So we're not differentiating between the corporate and the guest VLANs on this link from the wireless AP to the switch. All traffic is going to get sent up on the management VLAN. It's then going to go to the wireless LAN controller. When it gets hairpinned back out, that's when the VLAN tag is put on. So when we're using a wireless LAN controller, the link from the switch to the wireless LAN controller is configured as a trunk port, but the link from the switch to the AP is configured as an access port. So let's look at our configuration. So in our example, we've got the same two VLANs again, so we need to create the VLANs. So on the switch here, at global config, we say VLAN 21, name corporate, and then VLAN 22, name guest. Then, because we are using a wireless LAN controller, we also need to configure a VLAN for management as well. So I've said VLAN 10, name WLC management, and VLAN 11, name AP management. Now, in that example, VLAN 10, WLC management, is for the administrator to manage the wireless LAN controller. So you're going to need to go onto the admin GUI for the wireless LAN controller to configure it. You're going to need connectivity to it. So we've got a VLAN set up for that. In this example, we're using VLAN 10. We also have traffic between the access points and the wireless LAN controller. That is the cap-lap traffic. And in this example, we have configured a different VLAN for that. I've said VLAN 11, name AP management. So the traffic that is coming from the AP to the wireless LAN controller, which has come from the clients, that is going to be in the AP management VLAN. Also, management traffic coming from the wireless LAN controller when it's managing the APs, that is also going to be in the AP management VLAN. In this example, I used two different VLANs. I used one for when you, the administrator, is managing the wireless LAN controller, and I used a different VLAN for traffic between the wireless LAN controller and the APs. They would both have their own separate IP subnets as well. So you can do that. You can separate them out into two different VLANs and IP subnets, or you could just use one VLAN for both. So I could have just configured VLAN 10 name management, and I could have used that one VLAN and one IP subnet, both for managing the wireless LAN controller as the administrator, and also for traffic between the wireless LAN controller and the APs. It's optional. You can do it either way. Okay, so I've got all of my VLANs configured now. Now I'm ready to configure my ports, which are connected to the AP and the wireless LAN controller. I'll do the wireless LAN controller first. So again, when the traffic gets hairpinned back out through the wireless LAN controller back to the switch again, the wireless LAN controller is going to be tagging that traffic. So to be able to support the different VLANs, it needs to be configured as a trunk port. So I've got interface gigabit Ethernet 102, switch port trunk ncap.1q, switch port mode trunk, and then switch port trunk allowed VLAN 10, 11, 21, and 22. So that is the corporate and the guest VLAN, and also the management VLAN as well. They're all allowed on that link between the switch and the wireless LAN controller. Then lastly, I need to do my configuration for the switch port, which is connected to the AP. The configuration there, I say interface gigabit Ethernet 101, switch port mode access, and then switch port access VLAN 11, which was the AP management VLAN. So now all traffic coming from the attached wireless clients, no matter what wireless LAN they're in, is going to be sent up to the switch in that one VLAN, and it will then go to the wireless LAN controller from there. When the traffic is sent up to the wireless LAN controller, it does include information about what wireless LAN it is in. So because of that, the wireless LAN controller, when it sends the traffic back to the switch again, it knows what VLAN to tag it with. Okay, and this traffic is going up to the wireless LAN controller in that cap-lap tunnel. Okay, that was everything I needed to show you about the switch configuration. See you in the next lecture.